Hello everybody and welcome to day 2 of our printed hybrid in-mold and 3D electronics event. It's now my pleasure to introduce Masayuki R, who is the general manager from Asahi Kasei, and he's going to give us a presentation on the introduction of R2R printing technology for submicron resolution electrodes and applied devices. As always, please leave any questions you may have in the sidebar, and we will come back at the end of this talk and take those live. So Masayuki, over to you.
Thank you, Chris. I'm Masayuki Abe from Asahi Kasei in Japan. I want to talk about these topics. And before my talk, I want to show one picture. So this is today's technology. So this picture shows a transparent electrode and electrode for the TFT. And the left picture shows a fine white line and a black area. And the black area shows a PET substrate. And a white area is a copper electrode. And the specific point is this line width is 250 nanometer, not a micron. So this is our technology. So this is today's outline. At first, I want to talk about development motivation and our goals. And next, I want to show the submicron resolution printing roller mold. And after that, I want to explain about the high resolution roll-to-roll printing process. But because of Asahi Kasei's confidential, I can't show the detail of it. And finally, I will show the application sample and roadmap. So this is the first section. And so this figures shows previous printed electronic sensors. As you know, there's many previous good works. But I recognize that the problem is industrialization. So I decide to start development of industrial process. So this is our final target. So one of the target is a smart label for the logistics. I want to make product these sensors by using a roll-to-roll process. This is effective for the cost and the supply amount of the supply number. So in this label, there is some sensor module and wireless communication modules. Final target is a fully printed label, but midterm, I want to realize a hybrid type at first. To do such kind of high performance label, we need a high performance thin film transistors. This figure shows a common transistor structure, and there is a gate electrode, and there is a source and drain. And you can see the gap. We call this gap as a channel length. So this channel length is effective for the performance of the TFT. That is a cutoff frequency. It is influenced to the wireless communication hertz. So this equation shows a cutoff frequency, and according to this equation, I make some graph. X-axis shows the channel length, that means this L, and the y-axis shows the cutoff frequency. As you know, you can see from this graph, to realize from 100 megahertz to gigahertz, we need a very fine channel length. So I decided the target channel length